Leona, don't worry, we can't see your face. We're just looking at. Yeah, we got Robin and you. Okay, I need a link. Here, I'll just type it. How's it so fast? This is not good. Magic. Okay, so this will go live. I'll embed this video on our website. So yeah, it's basically a little bit, right? It's a different Oh, I don't remember my password to backstage. Really? It's delayed, yes. I meant to delay. Well, it's not meant to, but then it's kind of like recorded. It sends to the YouTube server and then shows up. So it's understandable. It doesn't really matter though. This means in the root, like when your last race is not the race valid, then you get a bonus. But if you're leading the race, you will be standing here, and then I will need you to take care of that last. Oh, here, sit here. Sorry, here. Sit here. You will be doing a lot of things today.
Really? I don't get to do it. I don't get it.
Oh, I like. Oh.
It'll be fun to learn how to do.
Yeah. Since you asked to learn about stuff, so basically all you need to do is sit here quietly because everything you say is going to be magnified by the microphone. I need all the three of you to be really quiet. Actually, excuse me, you. Sorry. I need you guys to be super quiet because everything you say will be broadcasted from the laptop. So basically, if you have anything that you don't want people to hear, don't say it. Just sorry, we didn't. We should have like zoned out this area, but we just decided this kind of last minute. So if you can just bear with us, like kind of speak quietly a little bit. We will really appreciate it. Thank you very much. One more thing I'm gonna do is to embed that thing onto our website so that people can see it from our website. And then I keep forgetting our login password. Yeah.
That's the worst password.
There we go. It's cold, so make sure nobody else comes in.
When did it get? When did this?
Page. That's new. See ya. And so oh god damn it. No, okay. You know what? So we have the link. This is the I'll take care of the website, the Facebook page, and all the other stuff. All you need to do is to make sure that people are quiet, and then make sure that this laptop doesn't really move. The camera is the webcam, so we couldn't make the other camera work. I think we need to figure that out us together after this, so that maybe tomorrow or the after later sessions can work. So right now, I'm just gonna post in the group. Okay, and then I'll work from my own laptop. Okay. So basically, you can see the screen, right?
Yeah.
So you want to make sure the screen captures, doesn't have to capture Leona, but to capture this screen. And the voice part is fine. Usually
Is it clear enough though?
That's the best we can do, to be honest. There's no alternative.
Oh yeah, because it's a webcam.
And once the session's over, just hit stop broadcast. Okay? Can you go back to the video and then can you turn on the sound so that we can hear it?
I turn it up.
Yes, okay. Okay, I'll just make sure a few other pieces of logistics. God, it's another full room. This room has a freaking capacity of 300 people at this moment. Hello everyone. Hello, your attention please. If you have a empty seat beside you that you are not saving for someone else, raise your hand. Raise your hand up high. Okay, those who need a seat, please find a seat beside these nice people. Thank you very much. How many seats do we have? Keep your hands up, please. Thank you. Be back at the end of session. If there's any trouble, call me. If the session ends earlier, call me.
Who's here?
You are here.
I mean, are they all? Is it like Michael, Sarah, Susan?
Back here. And Michael's will be here.
Michael is with the bodyguard.
Sorry, so these are all together. So that's your other job. Tell me what I guess.
Hey guys, so welcome to the CMP review session for the 290 finals. And my name is Leona, and right now I'm going to be going over this review package that I and the other CMP review instructor for 290 came up with. And this package actually worked alongside with Professor Graham. So you can rest assured that if you can manage to go through this entire review package, hopefully you'll be able to pass. By how much, I don't know, that's kind of up to you, but and I quick little announcement. Professor Graham does have office hours between 3 to 5 today, so if at 3 o'clock or anytime afterwards, if you guys feel like going through his professor's hours, I completely understand if you guys quietly left the room. And so one of the things that you guys covered for the midterm report was solving the sensitivity analysis, which is a long one. And so using a previous example that you guys have seen here is the party ball. And so for the final exam, you guys don't need to actually graph, but you guys should be able to identify which of these lines makes up the feasible region. And so in order to do that, you need to first find the equation of the line. And then it will be more preferable if you set it to B is equal to whatever x is. So that way it'd be easier to find the x-intercept or the y-intercept, so that way you'll be able to identify the line. And so for example, for the cutting, it's E equals to 630 minus 7 over 10s, and so the information is given from here. And then in order to find the profit maximization, you guys would take the revenue minus the cost, which is given from here, multiplied by how many hours it actually takes for these production lines. And then in the end, you should have the profit maximization. In other words, your objective line is 10s plus 9d. And then you also want to be able to solve for the optimal solution and optimal value. And then, as you can see, like these 2 points, they're the farthest away. So a quick way to determine what's the optimal solution is to decide that these two will most likely give you the most profit. And notice that at your objective line is 10s plus 9d. In other words, you're earning a little bit more profit from the standard bags. And so since standard is over here, you want to make a little bit more of that. And so the optimal solution will be here. And so you find this by, once you set these two lines, which is cutting and finishing, you set them equal to each other, and then you'll be able to find the point of intersection. Make sense? Yes.
Just like you recommend region is given to you, or
as for the profit maximization, it may or may not be given to you because it's supposed to test whether or not you can figure out what's the objective line. And so to go over how would you find this particular profit maximization, profit is revenue minus cost. And so the revenue is 82s plus 100d. And then once you find the cost, which is you multiply the cost per hour times how many hours you will actually use for each, you'll find that it is 72s plus 91d. And so you simply take 82 minus 72, and then you will find that the profit is $10 per standard day. Any other questions? This is pretty straightforward, so hopefully you guys are able to know how to isolate variables in order to solve for it. I hear a lot of murmuring. Is there some confusion? I heard a yes. You'll find out that this line is the cutting and this line is the finishing once you're able to find out what is the line equation. And so I haven't filled out all of them yet because it's something that you guys should be able to do. All the information is given here. So for example, the cutting line by itself here will be 710s plus 1e is equal to 630. And so in order to be able to find the intercept and clearly find out where to label it, you just solve, put down d is equal to the other side. So that way, it's kind of like y is equal to x. And then once you find that out, you can do the y and x intercept, and then you'll be able to outline which line is corresponds to which equation. Yes.
You want one? No.
Do you have a Sharpie? You can throw one. Probably not throw one.
Oh.
Bad coordination. Do you guys want me to re-outline it? No? Okay, I heard a long. Yes. Continuing on with the linear programming, another thing that you guys should be able to solve for the final exam is how to find the shadow price. Now, the shadow price is looking at how much you will increase the objective. So in this case, you want to see how much it will change for the profit. And so for finishing, you're going to be looking at if you were to increase the constraint by 1, how much more profit will you earn? And so by doing that, basically you're comparing how much profit you will earn by having 1 more hour for finishing time. So hopefully this is also familiar to you guys if you guys did spend the first half of the term on this. Any specific questions regarding shadow price? Okay. Oh, you want me to solve it? Okay, so in order to solve it, first you take the original equation for finishing, which is given from before. And so that would be f plus 2/3 e is less than or equal to 708. But then you want to see how much 1 more extra hour will give to you for a change in profit. So we're going to add 1. And then you just simply solve for d, so it'll be isolated. Then we have d is equal to 1063.5 minus 3 over 2f. And then in terms of finding the direct change, we want to set it to the cutting line because that is the point of the optimal solution. So we want to compare the new profit to the previous profit. Got it? RX. Oh, S. That would stand for standard. The standard bed, because we're comparing standard to the left bed. And now we set it to the cutting. And so now we're going to compare this to the cutting line, which is 630 minus 710S. And then we move all the S to one side in order to simplify things. So that would give us 8 over 10S is equal to 433.5. And so S would equal to 541.875. And then we take this number, plug it into the new finishing line in order to find D, and then we find D is equal to 250.6875. And so once we plug this into the objective function from before, which is, I write to this, 10S plus 9D. So we take these two numbers, plug that in, and we find that the new value for the optimal solution becomes 7,674.9375. And then we compare it to the old value of 7,668. And then we find that the difference is $6.9375. And if you're wondering where did I get the 7,668, it's from before. I didn't actually solve for the optimal solution itself, but once you set the cutting line to the finishing line, you'll find out that this is 520 and 252. And so you take these two numbers, plug that into here, and then you find out that the optimal value is this. And so we basically compare the new profit to the old profit, and then the change is around $6, $7. And so that will be the shadow price for finishing. So if you increase the number of hours for finishing by 1 hour, you will gain around $7 in profit.
How do you get the cost function on the last page?
On the last page. And so I got the cost function simply by multiplying out the cost per hour, in other words, the wage. And so you notice that for cutting, it takes up 1 hour, and then for a standard bag, it takes up 7/10 of an hour. And so you simply take 1.7 times 40, and then that will give you the total cost per hour for cutting. And then you do the same thing for sewing, finishing, and inspection. Add them together, and that's the total cost per hour to complete 1 day.
Thank you.
Okay. And now moving on, with the shadow price, you want to be able also to find the allowable increase for some equations. And so the allowable increase and decrease is basically saying how much can you change the constraints while still keeping the same shadow price. In other words, once you go outside of that range, the shadow price will change. So you want to see what is the range for the constraint for it to have the same amount of profit if you have to increase by 1. So here we are looking for the change in constraint. to find how much you can increase it to, because here it does say increase, we want to find how far we can take it to. In other words, we want to move up the line. In other words, for the finishing line, which is here. How far you can move the finishing line to the next intersection. Now, it doesn't explicitly show where is the next intersection, and so you have to be able to deduct for yourself. So as you can see, here's the cutting portion, which we found out earlier from these equations. So if you extend it, the next point of intersection will actually be the where it intercepts with the x-axis. And so to solve for that, you want to take the original cutting line here, and then put d as 0, and then simply solve for x. And then that will give you the coordinates of 900 to 0. So that will be the next closest intersection that you can move the finishing line up to, because afterwards it won't be defined in constraint anymore. So that's why it's the allowable increase. And so with that in mind, the next intersection, because it's 900 to 0, we want to input it into the finishing line in order to find the maximum constraint for finishing. And so the finishing line is once again S plus 2/3 D is equal to an unknown. That's what you're trying to solve for, the increase. And so because D is 0, we're just looking at S. So this actually equals to 900. And so now we compare the new constraint to the original constraint. And so before it was 708. So we find the difference. And then we get, you can move the finishing line up to 192. Yes? Question? That was why I was just quickly going over it, but I did have a request to show the calculations for it. And so with that in mind, you guys should hopefully also be able to solve for the coefficient of standard mix. If not, towards the end, if we do have time, I'll also go over this. Please also note how to define redundancy and binding. As Graham just specifically mentioned that you guys should know the definition for these two. Any confusion? And another thing just to quickly go over, you will also want to review the different parts of the sensitivity report. So be sure to know how to look at the optimal solution and find out what is the shadow type as well as the reduced cost. So that's another thing that you guys will be tested on for the final. And so now we're going to be moving on to the probability.
Video time.
And so now we're going to be looking over the random variables. And so here we have a question where it says the probability having a certain number of storms per year in delta are as follows. And so here it gives the number of storms that you have per year, as well as the probability of seeing these number of storms. And for this question, for part A, it asks, what is the likelihood of more than 2 but less than 5 storms will appear in 1 year? So this question is asking for 2 is less, it doesn't say, or 2 is more. It didn't say it's equal to, so that actually makes it easier. And so we want to find the probability of X. And so because each of these are just events, you can actually just add them all up together. And we know because it's between 2 and 5, X can either equal to 3 or 4. And so we simply take the probabilities of 3 and 4, which is 0.11 plus 0.04, and that gives you 0.15. So remember that for these events, you can add them together. And then for this question, if one storm has already been observed, how likely would there be at least 2 more storms for the year? So in other words, you're looking at a probability of, or a total of at least 3. And so the probability will be at least 3, given that you've seen at least 1 so far. And because this is a conditional probability, but as you can see, at least 3, that's already covered in at least 1. And so we actually just need to find the probability of at least 3 over the probability of at least 1. So that way this cancels out any double counting, because we don't want to count the probability of 3, 4, 5, and 6 twice. And so this actually gives us 0.11, which is for 3, plus a probability of 4, plus a probability of 5, plus a probability of 6. Divided by the probability of at least 1. And so this is the same thing as 1 minus 0.25. Now the reason for this is because, as you can see, if you add up all of these, it should equal to 1. And to have at least 1, you're basically saying that you see all of these numbers except for the number 0. So just to make things quicker, you can just do 1 minus 0.25, because that's not going to happen, because you already see 1. Alternatively, you could also add all of these together, but since you're in the final exam mode, you're not going to have the time to do that. So just simply do 1 minus 0.25. And then once you calculate that, it should be 0.24. That's the probability that you will see at least 2 more storms, provided that you see 1. Now for question C, it follows the same logic, except now it's asked for a total of 4 or more storms will happen in delta, provided that you already see 2. So now we're looking at least 4, since you've seen at least 2 so far. And so it actually follows part B very closely, but the wording is slightly different. And so now we have at least 4, so the probability of seeing 4, plus the probability of seeing 5, plus the probability of seeing 6. And just like how here we did 1 minus 0.25, because you're not going to see 0. In this case, because you already seen 2, it's impossible to see 0 storm and to see 1 storm. So we're going to do 1 minus 0.25 minus 0.33, and that should give you 0.1667.
On the part B, like if one storm has been observed, how come it's greater or equal to 1 is not just equal to 1? If only one storm has been observed, that like the probability is equal to 1.
Because the reason why we put down greater than or equal to 1 is because there's still the possibility of seeing more than 1. You only see 1 so far. but you're not for certain that it's only 1. Because if you say that it's given to exactly 1, then if it's exactly 1, it's impossible to see well, more than 3, right? Does that kind of make sense? Okay. Any other questions? Yes. The reason why we don't do that in this case because we're only looking at one event. If you were to draw a decision tree, you'll find out that it's only one stage. In other words, you just have 6 branches. Okay, yeah, that's a big tree. But there's like no other secondary stage for it, so we're only looking at the first stage. And so because of that, if we say the probability of more than 4 and the probability of more than 2, you'll notice that saying more than 4, that's already more than 2, and so that actually makes it redundant. And so that's why we simply just look at having either 4, 5, or 6, because it's still more than 2. Yes. So the reason why we divide this top number by the bottom number is because we want to eliminate any double counting in the way. Because once again, it goes back to the whole part of the question where more than 2, well, it goes back to the logic of more than 4, it has to be more than 2 anyway. And so we want to be able to eliminate any double counting because if we don't do that, then we're going to be counting 4, 5, and 6 twice in the probability. And then that will give us skewed results. Any other questions? Okay, moving on. So moving on to the second question of part 3. So here we have a person who is trying to decide how the probability of how many eggs and how many pancakes that she will have for breakfast. And so x in this case is eggs, and y is equal to pancakes. And so here it shows that if she has 1 pancake, the probability of her picking to have 1 egg to go along with the pancake is roughly 0.2. Well, in this case it is 2. And so that continues on, and you notice that for when she has 3 pancakes, the probability of having 2 eggs is 0. And so here it asks, what are the marginal probabilities of x and y? And so we want to be able to look at it separately. And so you're actually adding up the responses across. So the marginal probability of having 1 egg is 0.5 because 2 plus 1 is 2, 5. Hopefully you guys can do that. If not, that's a big trouble. As for having 2 eggs, it's also 0.5, which makes sense as it equals to 1. And no matter what, it looks like she will have at least 1 egg provided she doesn't have 3 pancakes. And so the same logic applies for y1, where we have 2 plus 3 is equal to 5, y2 is 3, and y3 is equal to 2. Now we're going to be looking at the calculating of the expected value and the variance for each of x and y. Now for expected value, this EV is equal to the number that you observe times the probability of it. That's just a quick way of kind of having formula for it. And so to do that for EX, we see that she can either have one egg, and the probability of that is 0.5. And then she can have 2 eggs, also 0.5 probability, and so that gives us the expected value of 1.5. The same sort of logic applies to Y, where she can have 1 pancake at 0.5, 2 pancakes at 0.3, plus 3 pancakes at 0.2, and that gives us 1.7. Now for the variance. The variance is slightly more complicated in this computation. It's also more annoying. So here we have we want to multiply the probability of seeing it as the number that you see minus what you expect to see, and you square that. I don't exactly know why we square it, but just square it. Otherwise, you'll get the wrong answer. And so, doing that with x, so the variance for x is equal to, for seeing 1a, the probability is 0.5, multiplied by, you see 1, but then you minus the expected value of 1.5, and then you square that. As well as for the other part of x, we have, once again, 0.5 probability of seeing 2 eggs, minus the expected value of 1.5, we square that, and that will equal to 0.25, if you add it. And so you also do the same thing with y, but I just kind of don't have room for that. So it's the same sort of logic where you do 1 pancake minus the expected value of 1.7, 2 pancakes, 3 pancakes, you add them together, and that will be your variance. And so now we will be calculating the probability of 1 pancake and, 1 egg and 2 pancakes. Because it's just equal signs, you just simply search it up here, and we see that it is 0.1. As far as the probability of 2 eggs and less than or equal to 2 pancakes, in other words, y is equal to 1 or 2. And so we find that by separating the probability and then adding it together. So we have the probability of 2 eggs plus 1 pancake, and then we also have the probability of 2 eggs plus 2 pancakes. And so looking over here, we see that it is 0.3 and 0.2. And so that is equal to 0.5. She has a 50% chance of either picking these two options. As for calculating the expected value of x plus y and the variance of x plus y, we're going to be looking at combining these two. And so here we have the expected. And so in order to help clarify the steps, you can just split it into different parts. So we can actually find the expectance of x1 plus y, and then add that to expectance of x2 plus y. And so that actually follows. Oh, sorry. Alternatively, you can also do the way of just having x plus ey, which is a lot easier. And in this case, you can just do 1.5 plus 1.7. and that would give you 3.2. This way is a lot easier. As for finding the variance, you unfortunately can't just add the variance from before that you calculated. You actually have to do the whole process of the probability times the value that you see minus the EV squared. And so this one, you will want to split it up as well. So x1 plus y. And so the probability of what you will see for x1 plus y is 0.2 starting with 1 pancake. So 2/10 times 2 minus 3.2. The reason why we have the number of 2 is because that's in total how many items that you actually have. So in other words, we're taking 1 egg plus 1 pancake equals 2 items. And so that's why the value that you see is 2. And then we do the same thing with having 2 pancakes. And so the probability of 1 egg and 2 pancakes is 0.1. And so here we have 2 pancakes and 1 egg. That gives us 3 items. Minus the expected value of 3.2 squared. And then for the last part, we have 1 egg and 3 pancakes. So that gives us 4 items minus the expected value of 3.2 squared. I just ran out of room, but it follows the same format as the previous one. And then for here, we do the same thing, but this time we're looking at the row of 2 eggs. And so for the row of 2 eggs, it's 3/10. And then 3 eggs plus 1 pancake equals 4 items. Yeah? For okay. for this is because this is more because it's x plus y. It's more like you're looking at the total number of items that you see. Oh, sorry, I see what you mean now. Thanks. They can actually see only 3 items when you have 2 A's and 1 packet. Really, I should go back to elementary school again. Yeah, can you guys try it down a little bit? You're going to have to repeat that.
Yeah, we'll bring over the microphone when you have a question, so everyone can hear.
And everyone, please quiet down because this person does have a question and it might be applicable to you guys as well.
We're supposed to check first whether X and Y are independent, because then it's receiving the tree.
I have received that question about whether or not you should make a tree. In this case, you can solve it without a tree, and I'm really doing this as shown by the professor. So, in determining what method you should take to approach a certain question, it will be best to ask the professor. So you can just send him a quick email because he will be the one who's marking it. So I'm not quite sure how much emphasis you'll put on how you do it, as long as it's still one of the effective ways to answer a question. And so now we're going to be moving on to question 3.3. You're going to finish this one? Okay.
Of course.
Okay. So basically, RF, it kind of continues on from the whole part A where there's expected value of x plus y plus the variance of x plus y. And in this case now is 10x plus 5y. What was the answer? Oh. Once you add these two variances together, it should equal to 0.56. And so to solve for question F, we're basically multiplying x by 10 and multiplying y by 5. And so this is what we can actually do. Using the expected value from before, we can just multiply it out. And so from before, we found out that the expected value for x is 1.5 and 1.7. So if we take 1.5 multiplied by 10 plus 5 times 1.7, we'll find out that it will equal to 23.5. And as for the variance, the probability between the 10x and the 5y is still the same. We're just simply changing from 1 egg to 10 eggs, from 2 eggs to 20 eggs. And then we do the same thing with y. So the probability actually stays the same because we're multiplying both by the same ratio. And so that's why we're able to just do 10 times x and 5 times y. And so that actually, we then followed the similar formula for variance, where we take the probability multiplied by what we see minus the expected values squared. So in this case, for example, if we were to do for x1 and x2, then for x1, then we actually see the probability of having 10 eggs and 5 pancakes is still going to be 0.2. What you see now is, however, 15, because 10 plus 5 is 15, minus the what we expect, which is 23.5, and then we square that. And then we do the same for having 10 pancakes and 15 pancakes. And then for having 20 eggs, the probability of 20 eggs and 5 pancakes is 0.3. And then what we see here is now 25 items in total, minus the expected value of 23.5 squared. And then we do that for having 10 pancakes and 15 pancakes. And then together you add the variance that you will solve. And then your total amount will be 25.25. Sounds good? Question? The variance for part E, the total answer is 0.56. Any other questions? Yes? The reason why I decided to separate it by x1 and x2, you guys can also separate it by y1, y2, and y3. I just did it by x1 and x2, so that way in the end, I only have 2 numbers to add together. So it makes it a lot less messy. You still have the same amount of numbers, but in terms of space-wise, I just prefer x1 and x2. You guys are feel free to do it y1, y2, and y3. Any other questions? Yes? Would you like to repeat that louder? Yes, we will be posting up the solution afterwards. So don't feel obligated to copy down exactly, as our solution is a lot more detailed. I'm just kind of going over the main ideas. So I will be able to go through the entire package and hopefully you guys will feel okay about it. The final solution either tonight or tomorrow, because we do have another review section for 290 tomorrow as well. Yeah. Well, you don't add specifically these two, but once you calculate the total variance for x1 and then total variance for x2. You add these two together, and that will give you 25%. I only did for having pancakes of y1 simply because I was corrected, so it doesn't show everything. Any other questions? Okay. Okay, so for question 3.3, this is asking for what is the probability distribution for the completion time of a project. And so for this particular project, we have 4 types of jobs. Job A, Job B, Job C, and Job D. And an important part to note is that it says that jobs B and C cannot begin until A is done. And D cannot start until C is done. So in other words, B can only start once A is completed, but it never said that C can start its job once B is done. So you can actually start job C at the same time as job B, and then job C and D are dependent on each other, so they follow each other. So in terms of a timeline, for example, we have 0, 1, 2, 3, 4, 5. If it takes job A 1 week, then we can put it here. But then for job B, it starts only after job A is done. And let's say that it takes 3 weeks. And so this is for B, the duration in this time. And then because C can start at the same time as B, we will have a second duration. And then we have C and D. So it's very important to be able to read the question carefully, because one of the more common mistakes was that you will assume that C starts after B, but they actually start at the same time. And so it actually changes out the total amount of time it takes for a project to finish. Because if we said that C starts after B, then you actually take a longer time, and that's not what the question is asking for. And so now we're going to be doing a probability distribution for the total project time. And so to do so in order to do a probability distribution, you get to draw a decision tree. And so here it says that you have 2 options. For job A, you can either take up 1 week or 2 weeks. So here we have A1, A2.
Thank you.
And then for here, for job B, it can either take up 3 weeks or 4 weeks. And then probability of C and D, because they're dependent together, we're going to add them at the same together as well. So we either have job C that takes up 1 week, and job D that takes up 2 weeks. Job C for 1 week and job C D for 3 weeks. So on and so forth. As you can see, doing this trees are quite time consuming, so if you're going to draw one, you want to know how to draw them quickly. And so now, you can also add in the probability that was indicated from before. So that's simply being able to read how the probability for each. So example, for the probability of completing job A in 1 week is 0.4. And then for having 2 weeks is 0.6. Hopefully your guys' decision tree are a lot more neat. And so for the question, the original question, it asks for the total project completion time. So once you fill in all of the different probabilities, you also want to calculate the total time. And now because jobs C and B can start at the same time, you actually want to take, it's going to be A, for total time is A plus whichever one is greater. So it's either the most of either B or C and D. Because B and C can start at the same time, but it's dependent on how long does it take for D that will determine what is the end duration time for the project. Does that make sense? Yes? Oh, okay, that's good to know. Any particular part that is confusing? Any questions? The D? Okay, so because here it asks for the probability distribution of the total project completion time. So you actually multiply out along the branches for the probability of how long it will take. And so you actually want to calculate what is the total time. In this way, it's kind of like our payoff, it's our end result. As for example, here, job A takes up 1 week, job B takes up 3 weeks. But then notice that job C takes up 2 weeks, and say that job D takes up 3 weeks. So in total, this here is equal to 5 weeks. And so that's why I say that for finding the total duration, because B and C can start at the same time, you want to find out which one is higher, either B or job C and D. Otherwise, you're going to be actually elongating the time duration. In this case, C and D is greater, so the total duration time for this is 6 weeks. And so once you multiply out the probability, you find out the probability of the project being 6 weeks. Question? How do you get this? Okay, so how did I get this 6 weeks is that you count how many weeks, but you want to compare which one in duration, either job B or job C and D. The reason for this is because job B and C can start at the same time. So that's why you want to find out which one is actually longer, C and D or just B.
Isn't it 5 weeks? 3 weeks and 2 weeks?
The reason for the total one is because, for example, if job A happens to be 1 week, and then while we have job B is equal to 3 weeks, if by chance, if job C is equal to 2 weeks and job B is equal to 3 weeks, that's equal to 5 weeks. So we take C and D because it's greater than 3, and then add that to A.
Oh, plus A is 1.
And so that's why it's 6 weeks. Why is the reason why we have to pick either B or C and D is because B start at the same time as E. If you read the question, because going back to the poll, it says that once A is done, we can start both B and C. So then C can only start when C is done. So that's why C and D are paired together. But then B and C can start at the same time. So in order to find the total duration time for the project, you want to pick which one is greater, either the duration for C and D or the duration that we call B, because they start at the same time. So one of them will be most likely longer than the other one. And so in order to find the maximum time, we just compare the amount of hours for C and D to B. And so that's why this total project is 6 weeks, because we have the 5 hours from C2 and D3, as well as the 1 hour from A. Does that kind of clear up the confusion as to why we have to pick the longest duration between B and C and D? C and D? Any other questions regarding how to calculate the total hours? I'll take that no. And so, if you find the probability distribution, you simply copy and paste the probability into the proper amount of weeks. You multiply it out, and that will give you the probability for each week distribution.
That's funny. Where's my sweater? My sweater. Other way.
So continuing on to the second part of this question. Now it says that the person is going to be receiving $10,000 as long unless it takes more than 5 weeks. In which case, if it takes longer than 5 weeks in duration, you'll only get 9,500 or revenue. So imagine that continuing on, if there was more paper space, it will be another column and it will say revenue, cost, and profit. Imagine these columns for continuing on to the side. Yes? The probability of C to D3, well, I guess I will just finish this part. So the probability of having 1 week for project A, for job A is 0.4. The probability of having job B take up 3 weeks is 0.5. The probability of having job C take up 2 weeks and have job B take up 3 weeks is 0.4. And so to find out the probability that it will take 6 weeks would be 0.4 times 0.5 times 0.4. Oh, sorry, I actually did that wrong. Thank you for correcting me. But it's actually, as he mentioned, it's actually 0.4 times 0.4. You get 6 weeks. On the right side, on the exam, you get that right. We're not getting the probability of building B. We're just looking at the overall duration of the project. So because for having 6 weeks, the project probability of this is 0.4. Because since we're adding the weeks for job A and job C and D, we just take 0.4 times 0.4, I believe. C1, D2. Let's call those C1, D2. For C1, D2? Yeah. For this particular question, I never actually went over this with the professor. As I understand, this is actually one of the problems that Professor Graham posted up on the net, as well as the solutions for his class. Yes, this particular question, it actually came from Professor Graham, and he posted up the solutions to it on the net. I'm not quite sure when he has posted it up. So for this particular question, you will want to ask him as to how to do this directly, because I never actually personally experienced a question like this, where the different types are actually the same. Okay, this for simplicity sake, just multiply along the branches. Just for simplicity sake, you just multiply along the branches for the overall probability. Make sense? That's why, just for calculating the overall probability, just go with the standard procedure of just multiplying across the branches. So yes, you multiply A with B and C and D. Just simply follow the procedure that you guys have learned in class. where you just multiply completely along the branches to find the overall probability. And so we're continuing on. Once you calculate the rest of the week as well as the probability distribution, the second part asks for the determining of the revenue, cost, and profit. And so, as said before, if it takes 5 or less weeks, you will get $10,000. If it takes more than 5 weeks, you only get $9,500. And then your total cost is $4,000 plus $500 every week that it takes to complete the project, as well as plus $500 for every week it takes to complete job C. So basically, once you find out for the rest of the weeks, you can align yourself. Either you'll get 10,000 or 9,500. And then as for the cost is a set amount of 4,000 times the number of weeks. 4,000 plus the number of weeks for 500, as well as $500 times for every week it takes for job C. And so you can figure this out by looking at the total amount of weeks as well as the number of weeks that it takes to complete job C, and that will give you your cost. And then you take revenue minus cost, and then you'll find the profit that you get for that project. Pretty easy. Yeah? For this one? Sure. And so the probability for this particular question, once you multiply completely along the branches, you're going to get 0.08.
What did you multiply to get that?
Pardon?
What did you multiply to get that?
This for the finding the overall probability, you just want to multiply across the branches, but that's actually not needed to find the revenue, cost, and the profit. And so in this case, for the revenue, because it took 6 weeks, it's more than having 5 weeks. And so your revenue is actually going to be 9,500. And then for the cost, it's going to be 4,000 plus 500 times 6 weeks. And it took job C 2 weeks, so it's going to cost $1,000. And so all of that for cost is 8,000. And so your profit is equal to 1,500. Does that make sense in terms of how to find the revenue, cost, and profit? And so now we'll be doing another decision tree. Because everyone looks. And so in this case, for this manufacturing company, you can either manufacture or purchase your part. And it's either going to be a low demand, a medium demand, or a high demand. And so in order to create a decision tree, we want to be able to list out. So in this case, you will either manufacture or you'll purchase. And then you'll either have low, medium, or high for each one. And so in order to calculate for the EMV for each, it says here that the probability of low is 0.35. For medium, it is also 0.35, and then 0.3 for high. And then the chaos, if you were manufacturing, you just write it down. And so in order to find the EMV for each part, you just multiply 0.35 times your payoff. And then you'll find out, and then you'll pick which one is the highest for the EMV. And then we add the EMVs together. So that way we'll be able to have like what is the expected value if you were to manufacture, but you don't know the particular economic conditions. So your expected value for manufacturing is 37, and for purchasing is 40.25. In this case, you want to purchase if you don't know what's the actual outcome. Any questions? Okay, good question. Next, would you guys like to move on to the second part now? And so the part it asks for the calculation of the EVPI. This is the expected value of perfect information. And so perfect information means that if everything was perfect, you know exactly what kind of economic conditions will be. And so that's why we're actually going to kind of flip this. So now we have low, medium, high. And then for each one, you can either manufacture, purchase, and so the payoffs are still the same though. So you can just fill it in. And so because you happen to know what is the probability for each, you can now do fill in the probability given from before. And then you can multiply it out, and so it should be the same. And so you can add in the total EMV for each economic condition. And then you find out that if you knew that it was going to be high economic conditions, you can expect to have 51. And so in order to find EVPI, we just take this amount minus from the E and B that we calculated from before, and then we find that to be, yes? This is also another acceptable way to do it. You can do whichever method that you feel is more comfortable to you, provided it still gives you the correct answer in the end. And so the value of the EVPI is 10.75 because we take 51 minus from the E and B from before, and we use 51 because it's the best expected value if we knew what was the economic condition. Question? We choose this particular one because it's the best that you can do if you knew what was the outcome. So in this case, you will actually want to manufacture if you knew it was in time. In terms of the different methods to reach the EVPI, you want to consult with your professor because it's also dependent on which method you're more comfortable with.
Isn't the second one a decision to choose which one's more optimal?
Right?
The second one is a decision, so you're supposed to choose which one's more optimal.
Well, it's more like, it's not a decision, but it's more like, the point of EVPI is how much are you willing to pay in order to have a forecast of whether or not it will be low, medium, high. In terms of a specific decision, you will probably want to manufacture, but the actual value of the EVPI is around 10.75. So the 51, that's the EVPI. That's the expected profit of the perfect information. Oh, there's probably one there. And this is a fun map arrow. I have to say, I am just following the SSP that we created alongside with the other CMP students. And so if there are any discrepancies, I suggest that you want to go through your notes as well as your assignments to double check. So right now we're having a little bit of a math discrepancy, and However, this isn't according to the solution that was given. There is a possibility that the solution that was given is incorrect. And so you guys will unfortunately have to go through the trouble of double checking it with your notes as well as with the professor, as we were given these projects. So sometimes there are just math errors, and hopefully we'll be able to solve this in time to post up the solution. That way it'll be correct. Now, because we are having some mathematical calculation errors for question 4, I and the other CMP leader will go over the problem to make sure that it's correct and we'll post up the solution. So for now, we are going to skip over question 4 until further notice because we want to be able to teach you guys the correct solutions as well as the method. So please be patient and we're going to simply skip over question 4 for now. And we are just going to move on to question 5. And in case you guys are wondering, to find the efficiency for information, it is EPSI over EVPI. And so moving on to the last question, which is the decision-making criteria. So here we have an apartment where we have the different blocks, where if you build an apartment building in good economic conditions, you make 50,000, and in poor economic conditions, you get 30,000. And so over in class, you guys went over the different approaches to how to make a decision. There is the optimistic approach, the conservative approach, as well as the approach with the least regret. Now for the optimistic approach, it's basically saying what is the best of the best. And so if you're looking at the best of the best possibility, clearly you want to look at the good times, in other words, the good economic time, because that's the best that you can do for each building type. And so by looking at this, the highest value is $100,000. And so the optimistic approach would be to build an office and receive $100,000 for that. As for the conservative approach, basically you want to pick the best of the worst case scenario. And so that will be looking at the poor economic conditions. And then you notice that the best that you can do if the economic conditions were poor is $30,000, and that's if you build an apartment building. And so the approach with the least regret, in a way you're going to be calculating for the how much you will regret if you happen to not pick another option in comparison to the one that you did pick. And so you want to compare between having the good times and the bad times. So in a way it's combining your optimistic and your conservative approach. And so you want to compare the optimistic decision to the other options. And then you want to compare the conservative approach compared to the other options. And then you want to calculate, well, not calculate, but to find the max regret from each apartment, depending on the economic condition. So let's say this is for apartment, office, warehouse. And now for comparing the optimistic to the others, it's 100 minus 50, 100 minus 100, and 100 minus 30. This is because the optimistic approach will give you 100,000. And if you pick the other ones, you risk losing out possibly 50,000 or 70,000. Now for the conservative approach, you risk out, in this case, 0. Now, because here it says that you'll have a loss of 40,000, if you happen to pick office and there's a bad economic condition, you risk losing a potential 70,000. And then as for the warehouse, you miss losing out 20. And so from these, comparing the good times versus the bad times, we want to find the maximum regret of that. And so this will be the 50,000, 70,000, and 70,000. And so you want to pick the smallest amount of regret of your choice. So that way, if it happens to be good times or bad times, you wouldn't feel that bad because in terms of regret, you minimize the amount of potential damage. And so in this case, it will be 50, taking the one with the 50. And so with the least regret approach, you want to pick the apartment. So luckily this is a lot more straightforward. Any questions about the 3 different methods? So right now it's 3:30 and we managed to end early. So if you guys have any questions, just feel free to come and ask. Because we ran hours, there's still limit for office hours. So if you also want to talk to the professor, feel free to go to his office hours for on the phone line. So afterwards, I will join your class.